Welcome to section 1.4, angles. So here's your title, and these pictures in the first slide a lot of times just sometimes something I think about when I think about angles. But let's get right to the lesson. I want to keep these videos as precise as possible. So an angle is a very popular word in geometry. There are two angle symbols I may have mentioned in the past, but I'm going to go ahead and officially show it. An angle symbol looks like a less than sign. I like to put the arc through it as well, just so I don't confuse it for anything else. So both ways are acceptable. You don't have to put the arc through it if you don't like to. But what is an angle? Basically, it has two sides and it meets at a vertex. And what's important to understand about an angle is the sides are rays. So we have to understand that this side here and this side here are what make the angle up. They are actually rays. So what I'd like to do is I'd like to, talk about naming an angle because I think that's a very, very important topic this year. So I'm going to go ahead and show a few ways to name this angle. And what is the actual angle? It's this measurement right here. It's how much of a circle this is, really. So we're going to name that angle, but there's a bunch of different ways. So let's get right to it. Let's see. The first way I'm looking at, one of the easiest ways, is we'll say angle A. I'm going to draw on the figure. C E, and it makes a roadmap and actually draws the angle. So if you're ever stuck with naming an angle, make sure that put your pencil to the paper and see if it draws the angle or not. So ACE is one way. There's many others. So let's get a few more. How about angle BCD? Take a look. BCD, absolutely same thing. Can I flip the letters around? Sure. Angle ECA, angle DCB. How about angle ACD? Then that means the reverse would be angle DCA. And I'm not going to keep going. You can see you can go DCB, BC. There's just so many other ones. So what I really want you to focus on, what is the middle letter in each of these? If you look, the middle letter is C in every one of them. So that's called the vertex. And that's I think of it like the point of the angle, kind of. It's like the pivot point, if you will. It's like where the rays kind of start off and shoot off this way forever. So we call it the vertex. And it should be the middle letter every time you name it. Now, there are other ways to name this angle. So I want to say you also could name this angle C. Now, you got to be careful with this one. I'm going to show you in a second. This angle C in this case is okay. But this is something we're going to be cautious about. I will show you in a second. There is one other way too. Sometimes you'll see this very popular way. It makes sense. You'll see a little 1 in here. It's going to be very tiny, but this is a number 1. You also can name this, if you saw like a 1 there, you could say angle 1. So that's some ways to name an angle. Make sure if you do it with 3 letters, by the way, that's the safest way, 3-letter way. Make sure it actually draws the angle. 1 letter is acceptable in some cases. And if there's a number like on the inside like this, well, that's probably the easiest way we can name it. So let's take a look at our next situation here. I kind of talked about these, and I had to draw on the last slide. So the names you can, those names I put, you can put right in here on your notes if you're following along with the outline. And the number angle C and angle 1 you'd be placing in here. But I couldn't show the picture and fit all this on one page. So it's no big deal if you put them all where I did too. Now the last part, this is what I want to slow down a little bit. Could I name this angle Y here, this right here? Can I name this angle Y? Well, let me go back and look at that other figure. I could name this one angle C. Could I name this one angle Y? I'm pausing for a second so you're thinking about it. The answer is no. Why could this not be angle Y, but the other one could be angle C? Well, if you take a look, there's obviously some other angles here. We've got this angle here. We've got this angle here. We've got, if you combine them, we have this angle here. So we cannot call this angle Y because we can't differentiate between these 3 angles. That's why we have to use the 3-letter method. So if you were trying to name this little angle here, you'd simply say angle X, Y, W, or YWX. If you were trying to name this entire angle, you'd say angle X, Y, Z. Hopefully that makes some sense. I want to make a very quick note over here. Cannot name, now I'm going to use a lot of shorthand, the angle Y, because there are 3 angle Y's. Sorry I had to squeeze it and go into the blue area there, but hopefully you can see that. Let's keep it moving here. So we measure angles in degrees, and I think most people know that already. You probably came across at some point in your life. If somebody goes off of a jump and they spin all the way around and face the way they started, we call it, oh, I did a 360. Well, a 360 is 360 degrees. You did a full circle, essentially. So, that's where we measure in degrees, and that's something we're familiar with. So the measure of angle A is determining by the opening of the side. So I'm looking at this angle here, this angle A, and once again, it's how far these rays, because remember, this is a ray, and this is a ray. I kind of think of it like an alligator, honestly, sometimes. When we're back to grade school, we did that with the less than or greater than sign, some of us. But I think of it like, how big does the alligator's mouth open? Like, that's the measurement in degrees. So we're determining it by the opening of its sides. Hopefully that makes some sense in the notes. And we classify them. You've probably heard these, so I'm going to go very quick. But angle A, this angle right here, is an acute angle. We basically say it's bigger than 0, but less than 90. And I'm going to go pretty quickly through these. This is an obtuse angle. So those jaws are stretched way out. That is an obtuse angle. So angle B is obtuse. It's bigger than 90, but less than 180. So you could have fractional angles, like you had a 90.5 or 90 and a half. Yeah, it would be obtuse. So I want to be very specific about those. And then a right angle. Now, we should hopefully know, it looks like the letter L, if you will, or a T. But I want to be very, very clear about something. We do not know that this is a right angle unless it was given with words, because I'm kind of telling you it's an angle that measures 90, or we see the box. You cannot assume that that's a right angle, angle C, without seeing this box or without some given. So be very careful in the future with that one. All right, and then we also have this other thing called a straight angle. Now, this is new. So think about the acute, the obtuse, we're opening up further. And then if we keep opening, like let's say we kept this obtuse angle going up here, it would eventually straighten all the way out to a straight angle. And this should look familiar, because if you remember, opposite rays, they form a straight line, and they form basically a straight angle. So if you look, like we've got ray AC, ray AB, all the way opened up away from each other, we would create this half circle, if you will, 180 degrees. And we would create a straight angle. I want to make official notes on that, so I like to sometimes jot these types of things down. Angle CAB, so that's how we would name it. CAB, vertex is still the middle letter, is a straight angle. So a lot of people didn't know about this. Angle CAB, these are official statements, is 180 degrees. And then I want to do the parts. This part's kind of important, just to understand the angles. Point A is think about it is the vertex. A lot of new terminology here. And ray AC is a side, and ray AB is a side. So hopefully you knew the acute, obtuse, right, and then maybe I introduced something new like with the straight angle. But you can look at them just the same. It's 2 rays with a common endpoint, just different types of angles. All right, let's get into some of the trickier stuff here. Well, first we have congruent angles, and that word's familiar. We've seen congruent before. Remember, it means more than equal. Equal in every way. But congruent angles are basically equal if they have the same measures. That's very basic definition. Adjacent. I see this word a lot, and I hear this word a lot. adjacent, they have to have a common vertex and a common side. There are some tricky things with adjacency, and I'm going to go over them in a minute, but I want to make some clear statements on this figure here. So make sure you have this constructed, and we're going to make the statement angle A, DB, and angle BDC are adjacent angles. I'm going to take a quick look at those real quick. So that's this angle and this angle. They are adjacent. I'm going back up. Do they have a common vertex? Yes, they do. D is the common vertex. Do they have a common side? Yes, they do, right there. Ray DB is the common side between those two angles. So that makes them adjacent. Basically, I call it they share a wall. And I like to think of, you ever see a double block house? When there's two front doors? Why not? Maybe I'll doodle a little bit here. So we've got a house, and we've got a front door here and a front door here, and there's a family lives in this side and this side. They are what we call adjacent to each other, and they share this wall. So it's the same idea. I got to get this out of here. My artwork is pretty bad. All right. Now let's take a look at what's not adjacent real quick. So angle, let me switch my color here. Go back to green, which means right. Angle A, DB, we'll start with again, and angle ADC are not, I want to underline that, adjacent angles. So that would be, I'm just going to erase all this for a moment. That would be this angle here, ADB and ADC. And as you can see, we have what we call overlap. They do share a vertex, and technically they have the same side in common, but they overlap each other. So I want to make sure that you understand overlap is not adjacency. And I'm going to go, I have another slide later on where I really reinforce this, but this is just so you have this quickly in the notes. And I want to talk about two more major ideas before we finish here. An angle bisector. You will see this word a lot. We had a segment bisector we talked about, but now we have an angle bisector. Remember, the segment bisector had to go through the midpoint. And that's of a line segment. Now we're talking about angles. So an angle bisector, it's a different idea, but it's also kind of the same. Bisector means cut into two equal pieces. So listen, this could be a slice of pizza. You have a beautiful slice of pizza. I don't know where from, but I'm sorry, I'm really hungry right now. But I see a slice of pizza, and if my friend wants that slice and I want that slice, the only fair thing to do is to cut that slice right down the middle. And that's exactly what an angle bisector is. Just a fancier way to say it, really. So let's take a look at that. Angle BAC. Is it the same size as angle CAD? Well, right now I don't know it is until I mark it up. But if I saw these markings right here, these are these two arcs, and I like to put these little tick marks. The book does it slightly different, but this is how I mark congruency. I am basically claiming that this angle here and this angle here are the same size. That's what this notation means, these little tick marks on the angle hoops. Okay, so angle BAC is congruent to angle CAD. And I'm going to write a triple dot. This is a new thing. Hopefully you're paying attention. This means therefore. I can conclude, or therefore statement. So if this is the case, I can now conclude, or therefore, ray AC, there's the key, is the actual angle bisector. So ray AC is an angle bisector of angle BAD. So I want to kind of go back through that again. I would maybe ask a question like this. Is ray AC an angle bisector of angle BAD? And here's what you'd say. You'd say, well, yes, because this angle is congruent to this angle. We know that ray AC is an angle bisector. So you can't say that this is an angle bisector unless you know these two angles are congruent. And our last idea is called the angle addition postulate. It's a very, very basic idea. This looks so confusing if you go ahead and read all this, and I'm not even going to read it to you. But that is the official angle bisector. Here's all it is. If you have this angle here, and you add it to this angle here, then guess what? You get this angle here. So look, AOB plus BOC. So AOB was this one. BOC was this one. It equals AOC, which is this one. So you can add two adjacent angles and make kind of a bigger angle, if you will. So you can, or subtract actually. I should throw that in there. Angle addition postulate, you could add or subtract. So I could also look at it like this. What if I said this angle minus this angle? That's kind of weird to think about. Probably, if I took away, once again, this smaller angle from this bigger angle, I'd be left with this, angle AOB. So you can add and actually subtract them. And please, if it's confusing when I first say it, please hit the pause button, rewind real quick, and check it again. All right. So we can also do the angle addition postulate on straight angles. So basically angle AOB here and angle BOC, we know that if it creates a straight line, it's equal to 180 degrees. And that's all that this slide is saying. All right, that's a protractor. We are going to go ahead and skip that for the virtual stuff. So when we get in the classroom, we might be able to do a little more with that. But for now, we're going to keep moving. Okay, we already talked about this, but this is where I go back in the lesson. You do not have to write all this back out. We kind of already did that in the notes. This is where I just reinforce. So I'm using red, which kind of means, I'm just playing around. Green means right. Red means, let me kind of just show you some new stuff. So what about adjacency? Let's get back to that idea. The angle 1 and angle 2 here are definitely adjacent. We share a vertex, we share a common wall, and there's no overlap. That's really what you're going to ask yourself. Angle 1 and 2, again, they are definitely adjacent. So let's look at what's not adjacent. That's kind of where you'll learn about what adjacency really is. What's wrong with angle 3 and 4? Well, don't they share a vertex? Yes, they do. Problem is they don't share a common side. See that? So this angle here and this angle here are not adjacent. Okay, angle 3 and 4. Angle 3, angle 4, they're sharing a side here. I see that. But they have two different vertexes. This one, angle 4's vertex is here. Angle 3's is here. And probably the trickiest situation would be 3 and 4. 3 and 4 are not adjacent. I kind of showed you that in the notes. They do share a vertice, and they actually share, they kind of share the same side, but as you see, angle 4 overlaps angle 3. You cannot have overlap for adjacency. Hopefully that makes that nice and clear for you. And back to an angle bisector, this idea, I just want to make sure you can use actual numbers in here. Is ray SZ an angle bisector? Yes, it is. And right here, there's the statement. Ray SZ bisects angle RST. I know that for sure because these 35s were sitting there. Now I got to blank the slide, and I'm going to move these out of here. If these 35s were not here, could I say that it's an angle bisector? The answer is no. You have to know, something about congruency, or they have to give you the measurements so you know. There was no markings of any kind. So make sure that you can confirm that this angle and this angle are the same size before you claim an angle bisector. And if it's an angle bisector, obviously, you can read these quick statements, RSZ and ZST. This angle equals this angle. So we cut the pizza perfectly is what I'm trying to say.